This talks on how to write a Salt renderer. Just a little bit of a background. Just a little bit about me in case you haven't dealt with me. My name is Erik Johnson. I'm a core engineer for SaltStack. I've been contributing for over 4 years now and been with the company for nearly 3 as a full-time employee. My Twitter and GitHub handle is TerminalMage. Hopefully I haven't been too mean to you online. And so with that, with those introductions out of the way, we'll proceed with the rest of the talk. So by show of hands, how many people here have used a renderer? So if you've used Salt, you should have raised your hand because everyone who has used Salt has used a renderer. They just may not know it. So what is a renderer? Well, since everything in Salt is data-driven, everything is a data structure, mostly dictionaries, renders are what we use to get data into and out of Salt. Although technically, I think out of, in some cases, could be interpreted as outputters, which are a slightly different use case. But in this case, for our demo today, we're going to be reading data into Salt. And so there's 2 main kinds of renderers. So your template renderers will always output a string. These are used to expand information into a bigger string, which is then processed by another renderer, which could be another data renderer, or it could be another template renderer, or it could be a data renderer. So the template renderers, the one that everybody's used to is Jinja. And that's going to take a bunch of text, and it's going to output more text. And then a data renderer it outputs a Python dictionary. And so with a data renderer, the data renderer has to be the last. The data renderer must be at the end of the pipe, because obviously you can't just load Jinja and just say, here, Salt, here's some Jinja expanded text, because Salt will not know what to do with it. So when you're using renderers, or if you're using anything other than the standard renderer setup, which is Jinja combined with YAML, you have to make sure that the last renderer that you use is a data renderer, or else errors will occur. So like I said before, the default renderer, if you're not setting one manually, is Jinja followed by YAML. But you have a great deal of flexibility in changing it on a file-by-file basis by using like a shebang syntax, similar to if you've used to writing shell scripts or Python scripts. You'll be familiar with this sort of syntax. There's an example there below the default of using 2 templating systems. Jinja will be processed first, then all the Mako templates will be processed second, followed by loading into data structure via YAML. There's also an example here of using JSON and the pure Python render. So the first line of the file basically will determine what type of renderer you're using. And if there's no shebang at the top, it just assumes the default. So renderers, they're only a single function. They're one of the easiest pluggable systems in Salt to extend. The render function has to return a dictionary. Those are the only 2 requirements. I couldn't even fill out the slide with additional information. It's literally that simple. So now we come to the humorous part of the slide. You may be wondering why all of a sudden this 2-year-old meme has invaded this presentation. And the reason why is our demo today is going to be on Dizon, otherwise known as Dizon. This is a JSON-like syntax, which with the punctuation replaced by Doge terminology. The URL there is a very old, not very old. It's a mirror to the original website, which is down in it used to be just dojon.org. So that is somebody has mirrored the website containing the spec. If you'd actually like to read the spec, it's quite humorous. You can do it at that URL. So Dizon is exactly like JSON in almost in how it's structured. So with JSON, you're not able to use trailing commas like you see in the example below there. That would be a valid Python dictionary, but that would cause an error if you try to load that as JSON. Now, if you try to put an extra punctuation at the end in Dizon, it's the same thing is going to happen. So a dictionary, hopefully that bit at the bottom is readable. So a dictionary will start with such and will end with wow. The left curly brace, think of that as the word such. The right curly brace, think of that as wow. And as you can see, in the first loading example there, we have a two-element dictionary. The key value pairs being key is value. All of that can just be directly translated to JSON if you know what you're looking at. And the second example there, we can see a nested dictionary. The is value is just another such, meaning like the beginning of another dictionary. No. Lists, they will start with so and end with many. So is the open bracket, many is the closed bracket. Instead of comma-separated values, they're separated to make it a giant run-on sentence. The punctuation or the separator is either the word also or and that can be used interchangeably. It doesn't matter. It doesn't matter. I could have done both also. I could do also bas, also one. It would have worked the same way. And then you could see you could see how it's all inside a dictionary because it's prepended with such and ends with wow. So that's just a brief introduction to this goofy language. So today we're going to do a demo. I'm going to actually write a render that'll load this type of text, and to do that we're going to use the Dojon module, which provides an imported name of Dizon. So it works exactly like the JSON loader. And so if you look at the spec that I posted on a previous slide, there's some complex numerical expressions. These bindings do not handle that very well. Another thing, this is obviously meant to be kind of a joke. I wouldn't recommend using this in production, but knock yourself out if you want to. So now we've come to the the actual live demo portion. Apparently. So I've gotten this started out with just so because I didn't want to type all this junk. This is just some stuff we have for Python 3 compatibility and some initial imports. We're importing the Dizon module and setting up logging. So first thing that you see, and this is just a convention that we see in a lot of renders, is that they can take either a string as input or a file handle. And so the first thing we're going to do is we're going to account for the instances in which you have a non-string input. And what we're going to do is we're just going to read this in. So now we've converted the file handle to a string. Here, this is something that you don't find in many renders, I prefer having some logging. So I'm just going to do, that's why I set up logging earlier up at the top there. Because you never know when you might want to troubleshoot your Dizon. Now we got a helpful logging message. The next thing we want to do is we want to account for the fact that the beginning of the file may have one of those shebangs in it, and we don't, and that's obviously going to cause the loader, the Dizon loader to error out because that's not valid. So now we've checked here. If it starts with a shebang, we're going to lop off the first line of the input. To do that, we're going to look for the first occurrence new line. I don't recommend typing with your head over your shoulder like this. It's not that easy. Okay. And then we're going to advance one character over from that. Hopefully that long string makes sense. We're going to say, if this starts with a shebang, go to the place after the first new line and start the string there. And so now we've cut off the first line of the file if it has a shebang. And from here we're nearly done. We obviously, if you pass an empty string into the loader, it will also error out. So we're going to say that if we have an empty string now, and this accounts for leading and trailing white space, then we're just going to return an empty dictionary. And failing that, we have some Dizon and we want to load it, so we're just going to return and again, this works just like JSON. And that, assuming I haven't made any typos, is it. So, going back to slides. I have an imager link if anybody wants this at the end. So now we're going to write some states using our newly written render. And so to write states, it's helpful to first understand since we're dealing with data here, the data structure in which we'll need to work. So with YAML, everywhere you see a colon there, that is a dictionary. In the case here, you have a dictionary, the top level key being ls-l. Its value is a nested dictionary, which itself points to a list of elements, each of those being a one-element dictionary. So, to reproduce that, we end up with something that looks like this. This being a dictionary with another such wow and a list of parameters, each of them one-element dictionaries. So it looks a little bit like this. So state.apply, I'm not sure if people are familiar with state. Not everybody here may be familiar with state.apply. State.apply is basically just a convenience function. It's what I recommend people use because frankly, state.highstate and state.sls don't exactly tell you a whole lot about what you're doing. This says you're applying something. If you pass it any parameters, it's going to run state.sls and run individual SLS files. If you don't apply if you don't include any parameters after this, it's going to run a high state. So it's a nice little one-step function, so you don't have to remember to run. You don't have to remember which function you need to run. And what is that file called? So let's take another look in there and look at this, and this is just a simple ls-l in the temp directory. We should just get a ls-l output here. Again, unless I totally mess something up. Oh yes, it helps if I'm actually running Salt. My laptop, I accidentally held down the power button for too long, and so now I have no Salt daemons running. So we should start those up. There's always something in a live demo, isn't there? And there you see we have our ls-l. And you see the files that are in the temp directory. So I know what you're thinking now. I can run states, but can I do templating? The answer is yes. And it looks even more ridiculous. And that's what we're gonna look at next. After I replay this slide. So here's an example of cycling through a list of usernames, doing a user.present. Dizon having a little bit more inflexible syntax requires us to have the ands and alsos, but only after the first and not after the last, or after every element but the last in the long string that defines our list. So to do this, to cycle through, we have to come up with our little also to connect the list together, but only we're going to put the also before the name of the stooge here, and so we're only going to do that if the index that we're incrementing here is not 0. Interesting thing with Jinja, a lot of things that you think might work won't. Int, float, len, all don't work. They all have to be done with this little pipe syntax after the name. So, but oddly enough, range works. Don't ask why. So let's go to the demo. And we can have a look at this same SLS here. Oh, I actually left it as absent when I was cleaning up my earlier test with this. Let's change that to present. And rerun this. And we have 3 brand new users. So if we want to get rid of them, we can do what I just did. And now we've gotten rid of all 3 users. So that is templated Dizon. This is intentionally ridiculous. So with that, we've come to the end of the demo, and there's plenty of time for questions. Go ahead. It should be in the debug log, yes. So let's see, should be up here. Oh, yeah, it's rendered here, so Dizon input. Where would it? Oh, you know where? You know why? Because I use salt call. So let me just run it again. Yeah, with -l debug. That's why it didn't show up in the minion log. So, see, I didn't use the non-white space creating version. So there's a lot of white space here because of the extra Jinja. So there's our 3 users. And there's the rest of the render Dizon. So many wow. So yes.
If your minion is part of an execution which run a command and the standard output within Dizon, what would you use to convert that back to a dictionary so that you can set it back on the test?
Can you repeat that?
So if you're running a command on a remote on a minion, and then the output of that minion, the standard output is in Dizon,
Yeah.
you want to basically parse that and then send it back to the event stream, what would you use to do that?
Parse and send. The output is that. Are you talking about the output of a function or some external application?
External application.
So you're talking about like some sort of command line utility for doing this?
Yeah. So if you're running a command line utility.
Yeah.
And the output of that, instead of just dumping it in standard out and sending it back, you actually want to parse that as a dictionary and then send it back to the dictionary.
I don't know of any way of doing it besides running it through a loader like this. This was and also this example, obviously, like I said, this is intentionally a silly example, but the more often the more I guess frequent use case for using a non-standard render is something where you don't have to jump through hoops and do dictionaries with nested dictionaries and lists. The only time I've ever heard of somebody using a custom render or a non-standard render is for something like pillar data, where they're programmatically defining pillar data. So you may have something that's some sort of data store that outputs JSON, and then that JSON is then loaded using the JSON render to give you your pillar data instead of YAML. It's not something that you don't write a new renderer to write states typically, because the idea usually is to make them human readable, which is why we use YAML. A better example for a custom renderer might have been pillar, but it wouldn't have been nearly as funny. So, okay. Anybody else? Any other questions? Correct. The question is the bindings would have to be available on the minion. That's correct because the SLS files would be pulled down. And that question is the answer to the question is not necessarily if you're doing it with the pillar example, because pillar data is rendered on the master. However, if you're doing SLS files, if you're being goofy like this, those Python bindings do need to live on the minion, because how the minion works, or how the state compiler works, is the SLS is pulled down from the master and then rendered directly locally on the minion. So yeah, the answer, that's a long-winded way of saying it depends on the application, but for running states, yes. For running pillar, you would just need it on the master. Is that everything? All the questions? Okay, I think we can wrap up early.